Example 11 asks us to express each of the following in terms of the sine of theta, the cosine of theta, or the tangent of theta. So sine of 90 plus theta. Well, we don't really know how that works entirely yet. So we have to somehow equate this to something else that we can work with. So let's try some different things. So if we're dealing with the sine of 90 plus theta, I know that there's a rule that says that the sine of theta is equal to the sine of 180 minus theta, or 180 degrees minus theta. Right? If we think about on the unit circle, if we move this way, that way, we end up with the same y value, the same height. So we know that to be true. Well, if we try to model this same formula, theta is 90 plus theta, then this would mean that that has to equal the sine of 180 minus 90 plus theta. Okay, so this is a true statement, right? We're matching it exactly how we need to. So based off of that knowledge right there, we could say, okay, well, the sine of 90 plus theta, that's the same thing as the sine of, this is 180, then we have to subtract 90, and remember, the negative is going to extend to the theta as well, which ultimately means here that this is the same as the sine of 90 minus theta. Well, how about that? So if we were to add an angle to 90 or subtract an angle from 90, we end up with the same sine value. And again, that logic makes sense. If we were to add from 90 or subtract from 90 the same amount, we end up with the same y value. How about that? So this angle and that are the same. Excuse me, that function and that function are the same. Well, what's the sine of 90 minus theta? That is the same thing as the cosine of theta. So if we were to add 90 degrees to an angle and plug it into sine, we get the same values if we plug that angle into cosine. It's quite interesting. The next function we had, they asked us about, was the cosine of 270 degrees minus theta. Okay, well, this is a little different. So we're talking about taking this angle and going backwards. So how would I equate that back? So we need to figure out something that this actually makes. So we know that if we were to try to convert this, okay, we can say that, hey, 180 degrees, all right, if we were to add 90 minus theta to that, okay, if we added 190 degrees plus that, we end up with 270, okay, minus theta. So we know that these two things can be equivalent to each other. So what we can say is that this is going to equal the same thing as the cosine of 180 minus 90, or plus 90 minus theta. Okay, well, if we were to add an angle to, from 180 degrees, so if we had some angle, 90 minus theta, and added 180 degrees to it, so even if we go all the way to the other side of the circle, right, the cosine is actually the opposite. Okay, so this thing here is actually the opposite of the cosine of 90 minus theta. Okay, because we're 180 degrees away from 90 minus theta, okay, we get that. So you can see that, again, 270 minus theta, or if we add 180 to that, or take 180 from that, we can get to 90 minus theta. So we get to this point here. So it's the same thing as the opposite of the cosine of 90 minus theta. Well, we knew earlier that the sine of theta is the cosine of 90 minus theta. So if the sine is equal to the cosine of 90 minus theta, then the negative cosine of theta would equal the negative sine of theta. So ultimately, what this is going to equal for us is the opposite of the sine of theta. So lots of little jumps here, but we're making connections around the circle. That's what we really want to do, is try to make connections back to things that we know. So there are multiple ways you can go about some of these problems. I'm just showing you one technique. And then our last problem asks about, so this is different, the tangent of 3 pi over 2 plus theta. So 3 pi over 2 plus theta. So we're going this way. So we could think of this as thinking about something complementary. What if we went backwards? How could we find that same value if we were to go backwards? Because we do know something about about 2 pi minus something. So we're going to look at that angle. So if we were to say, okay, well, 3 pi over 2 plus theta, if we did 2 pi minus an angle, how could we get to that? If we did 2 pi minus, what would give us this? This would be pi over 2 minus theta. So 2 pi minus pi over 2 makes 3 pi over 2. And the negative, subtracting a negative theta gives us a positive theta. So we can say right off the bat that this is the same thing as the tangent of 2 pi minus pi over 2 minus theta. So this is the same idea as using 90 minus theta. So if we know that this part is true, so if we, what happens to a tangent value when we subtract it from 2 pi? Well, we end up with actually the opposite value. Remember, tangent, if you think of tangent, think of the slope of a line that when it runs into the origin. So these are going to be the opposites of each other. So this is actually the same thing as the tangent, excuse me, the opposite of the tangent of pi over 2 minus theta. Well, we learned before that the tangent of 90 minus theta, or pi over 2 minus theta, same idea, is the cotangent of regular old theta. So again, if it's the negative tangent, that means it would make the negative cotangent, excuse me, the negative cotangent. Okay, so we're going to go and we're going to say, okay, so it's negative cotangent of theta. So we go back, say the negative cotangent of theta. Well, it actually asked us before to write everything in terms of sine, cosine, or tangent of theta. Well, the cotangent of theta is actually the reciprocal of tangent. So we could finally say that this is the same thing as negative 1 over tangent of theta. So this is a lot of kind of moving things around in your head and trying to figure out how to match different pieces together. So the try it, you want to use this very closely as an example for how you would deal with these different parts and really try to equate these things together. And if you can get this example, you're going to do very well with the rest of this unit. If you're having trouble, don't worry. We can work with this in class.